Hi there, in this video I'm going to show you on how to build a multi-agent architecture for machine learning. So the architecture would look something like this. You will have multiple agents which are going to do machine learning. So you'll have a supervisor agent which is going to supervise all the different agents. You will have a data profiler agent, a data preparation agent, model training agent, and model evaluation agent. And all these agents are going to share state using this shared state object. Now, you can give a prompt such as use the data set, make a machine learning model to make some predictions, and you can also define a target accuracy. So all these agents are going to collaboratively work with each other in order to achieve this target accuracy. So before we go into building, let me first define all the different key concepts which we'll be using while agent building. So you'll need an access to large language model. You can think of this as the brain of the agent. And then you'll also need access to some tools. So you can consider this as the hand. So this is where all the Python code, machine learning code is going to be executed. And then you also need to define a system prompt, which is the behavior of the agent. So basically an agent is a large language model plus tools plus prompts. So I'm going to show you on how to build such an agent using my platform called as data-jarvis.ai, and you can also try it out. It is free to get started. So first of all, let us define the user credentials, and I'm logging into the platform, and let us now start building an agent. So here you see a default agent which has got a name, and let us give it a name such as supervisor. And we also need to define the large language model. So I'm using this large language model which is Claude IQ 4.5. Now you also need to define all of the other agents. So let us define the agent which is the data profiler, and let us also give it access to the large language model. We also need to define the tool nodes which this data profiler will need, and we need to connect the data profiler to the tool node and back. And we also need to define the key on how the tool node will be called. So that is using this tool calls as the branch key. Similarly, we also need to define our third agent, which is the data prep agent. Also give access to the tool node, connect both of them, as well as give access to the large language model, and also define the branch key from the data prep to the tool node, which is the tool calls. Now, let us also define the next agent, which is our machine learning agent or the model training agent. So once again, we give access to the large language model, as well as we are also going to give access to the tool node. And once again, connect both of them and define the branch key from the LLM to the tool node. Now, let us also define our last agent, which is the model evaluation agent. So once again, we will give the name, and we will also give access to the tool node and connect both of them, and also define the large language model, as well as we can also define the tool calls key on how the model will pass the work to the tool node. So I think we have defined all the agents, and I think the architecture is kind of looking good. Yeah, it's a good architecture. It looks pretty solid. And let us now also connect all these different agents to each other. So we can connect the supervisor agent to the data profiler agent, and whenever you connect, you have to give a branch key when this connection is going to happen. And I've given done, which I think is wrong, because done goes to the very end. So we need to define that you will go to data profiler. Let's define a key such as continue. So that supervisor has got three keys: done, continue, and tool calls, and I'll tell you on when these keys will be called. But let us connect all other agents such as data profiler, data prep to model train, and model train to model evaluate. And from model evaluation, we can go back to the supervisor node. So this is taken if the target accuracy is not achieved, we need to rework the model training. That's why we have to take it back to the supervisor agent. Now, all these agents are going to share information through shared state. So let us define the attributes of shared state, such as number of runs. We can also define the model accuracy, as well as we can also define the target accuracy. So this is target accuracy is given by the user. We can also define different variables which are going to hold information related to the output of all the agents. So data prep, data profiling, model training, as well as model evolution. As well as we can add one more variable, which is this prepared data set, which is the data set with the data preparation agent is going to create, which could be a new data set compared to the original data set. So I think we have done all the connections. We have defined the shared state. Now let us define the profile and let us define the prompt, as well as let us define the tools. So supervisor agent will have access to the update shared state tool, and let us define the behavior or the prompt of this particular agent, which is you are an agent which is going to supervise sub agents, and you are going to receive data set, target column, target accuracy, and update the shared state. And then you should also read the number of runs and machine learning accuracy. If the accuracy is more than the target or number of runs is more than 10, then you have to emit done. Otherwise, you continue. So this is going to define the value of the key and the way in which the branching is going to be done. So either it will be finishing or it is going to continue. Now we also need to define this routing. So the routing here is based on the agent decision, which could be done, continue, or tool calls. Now, I think this agent definition is kind of looking good. We have defined the tools, we have defined the prompt, as well as we have also defined the agent routing. Now, all other agents are going to be a bit simple. So the data profiling agent, let us give access to the update shared state as well as the profile data tool. And let us define a prompt, which is going to be very simple, that you are an agent for data profiling. You can use this tool. You should write the result back to the shared state in this particular variable. And once the work is done, you can pass the work to the next agent, which in our case is the data preparation agent. So let us now also rename that so that it is correct. We also need to do the same thing for all other agents. So let us do that. We are defining the prompt. We are also giving access to the tools which are required. And then we also have to define similar prompts which are required for all these sub-agents. So let me kind of do that in a rapid way. So this prompt is important. It is also important that you define the prompts in a very clear way, in a very detailed way, because this is going to help the large language model take an accurate decision. So in this case, we are defining that you should run one model per turn. And this is good because it is going to try out one model, and then if it doesn't work, it is going to try out some other model. So yeah, so you can bring all your data science knowledge, what you have, into defining these prompts. Now, similarly for the model evolution agent, we need to define the tool as well as the prompt, which is that you are model evolution agent and you are going to work on this prepared data set, and then you are going to evaluate the model and you are going to write back the results in the shared state. So I think we have defined all the tools. So let us now save this agent. There is a lot of work which has been done. So let us save it, and let us also validate it just to see that if everything is green. Yes, we have a valid flow, which is good. So I think our agent is ready and we can start working with it. But let me first show you also the data. So we are going to work with a data set which is for telecommunication customers. So this data set is going to have different fields on demographic of the customer, as well as it has got information on if this customer has left or not, churned or not. This is what we want to predict. So I think our agent is ready, data is ready, and let us now start using it. So we can give a prompt such as use this data set and develop a machine learning model to predict the churn. And we can even give that we want a target accuracy of more than 80%. So you can see that first it is calling a tool to update the shared state, as well as it is now going to the profile data agent, and the data profiling agent is in action. And you can see that it has come out with the recommendations for data preparation, which is pretty fascinating. Now it is going to pass the work to the data preparation agent, which is going to take the input of the data profiling agent and do the work accordingly. Now it is going to pass the work to the data model training agent, and it is going to use an random forest algorithm in first try. So let us see what is the result of the random forest algorithm. So we have an accuracy of about 78, which is a bit less than the target. So let us see on what the agent is going to decide. So agent has decided that yes, it is going to go to the next model, which is gradient boosting. So this is pretty powerful. The agent is deciding by itself on what actions have to be taken based on the objectives which are given. So now it is trying this random with the gradient boosting, and you can see that yes, the accuracy in fact is more than 80%, which is pretty good, and it is updating all this information in the set state. And it has also given this information that the run 2 model accuracy has been achieved. It has given also the final summary of the different model it has used. It has also given the key insights and recommendation. So this is pretty interesting, and now it is passing the work to the model evaluation agent. And the model evaluation agent is going to evaluate the model. It is going to produce all the performance reports, and it is also going to update the shared state. So now we have the final result that the work has been complete, which is fantastic, and it has also given a kind of a neat summary as well as this report on model evaluation. So it has used the gradient boosting, it has given the confusion matrix as well as the top feature importance. Now you can also see that it has given a very nice workflow summary, that it started with data profiling, it started with data preparation, then it went to model training, it tried 2 models, and then it went into the model evaluation. So this is pretty powerful because as a user, you do not have to think about different decisions. All the decisions are taken by agents. All the agents are working collaboratively with each other, and they are getting the job done. Now, let us see also some key takeaways. So first of all, that agentic machine learning is the future. And you should stop building machine learning manually, but instead you should build agents that will do machine learning for you. And if you want to try out to build an agent, you want to try out the video, what you saw, you can go to my platform called datajarvis.ai and you can try it out. So thank you for watching. Please do subscribe to the channel, like the video, and see you soon in another exciting video where I will build another exciting agent. Thank you. Bye.